Welcome to Richardson RFPD's Tech Chat. I'm Zhang, a field application engineer for Power Products. Today we welcome GaN Systems staff application engineer Roy Ho. Hi, Roy.
Hi, Ray.
Hey, we have a lot of customers who want to reduce power supply size and reduce cooling component cost. For example, they want to design a high power density AC to DC adapter using your GaN devices. With this background, I'd like to ask you the question that what are the best practices in thermal design in such a high density converter?
Yeah, that's a very good question. And we do see the GaN-based adapter is booming on the market. So we are very glad to be able
Right.
to address these questions. So just let me share my screen. All right. Can you see my screen?
Yes.
Okay. So here we give you the best practice on adapter thermal design. And the rule number one is the thermal conduction is still the most effective heat transfer path in the adapter. Therefore, we want to have a very good vertical heat transfer with material have high thermal conductivity, or
Hmm.
AKA the K value. And by saying so, we can see the figure below here is ideal location for our GaN device in the adapter.
Hmm.
And it works best by placing the GaN on the side close to the adapter case. And this is the best spot for heat dissipation.
Hmm.
And it should work well for high power adapter, as usually engineers have GaN on the daughter card for high power adapter, and then we
Hmm.
can just place a daughter card on the side close to the adapter case. And for low power adapter, as the space is so limited, so you might also need to take the power density and the space availability into consideration.
Hmm.
And then you might just want to place again as close as possible to the case and with a good thermal conduction path.
Right.
And here in the figure, as a device is bottom cooled, so we just mounted it upon the PCB, and the heat is transferred vertically through the copper of the PCB to the copper slug, to the tin, and then to the shielding copper, insulating material, and finally down to the adapter case.
Hmm.
And, and
Roy, just one question. By low power adapter, what do you mean by low power?
Oh, so for example, like 65 watts adapter. So usually people will not apply daughter cards for such small adapter. There's no, because once you see a 65 watts adapter, you know the
Gotcha.
size is just too tiny.
Yeah.
And so people usually don't apply daughter cards in such small adapter. But
Right.
usually for like a adapter about like 200 watts or 300 watts, it's a big one, right? If you have
Right.
some, entertainment laptop, you will have those big power adapter. And you see how much big it is. And for such adapter with such size, people usually will apply like this daughter card into it. And
Hmm.
it's a good opportunity to reduce the size.
Sure.
Okay, and and another key room for thermal adapter, I would say, is the horizontal heat spread, and it's actually also quite critical. And therefore, the tin and the copper shielding here play a big role for the heat spread. So to sum up, to improve the thermal performance in the adapter, we want to have thicker PCB copper,
Hmm.
adding copper slug, filling gap with thermal glue, better tin material, and thicker copper shielding. And in fact, the copper shielding is very important in the adapter, not only for the EMI reason, but also for the thermal reason. And here we show you our recent release, the new 100 watt dual USB-C PD adapter reference design. And on the right side, we apply different adapter copper shielding thickness, zero point 0.2 millimeter and zero point 0.5 millimeter. And below, we can see the different results. And we can see that with thicker copper shielding, we get more even temperature distribution on the adapter case surface.
Hmm.
And it's going to help you reduce the hotspot temperature and thus lower the maximum surface temperature on the adapter. So the copper shielding is really the critical item in the adapter thermal. It helps you on the EMI, help you reduce the key components junction temperature, and also help you on the adapter surface temperature reduction.
Wow. Yeah, thanks for the good tip. I see that adding the copper shielding is very important in the adapter design. And just want to ask you one more question. Is the 100-watt design available from your website?
Oh yes, it's available on our website.
Okay. Yeah, what is the power density?
So usually our reference design provide about power density in 18 watt per cubic inch. And
Wow.
for this particular one, it's roughly about 17 watt per cubic inch.
Wow. Yeah, that's very impressive. Yeah, it shows you how efficient GaN is. Yeah, I think that's all my questions. Thank you very much for participating in the chat today,
Yep. Thank you, Ray.
and thank you all for watching our tech chat video. As you can learn more about this and other related topics from the tech chat session of Richardson IPD's GaN and Silicon Carbide Tech Hub website, just click Ask an Expert link if you have any other questions. An expert will get in touch with you shortly. Thank you.